Hi, I'm Ryan Munn, standing here with Mike Strang of Strang Farms. Mike did a presentation for our Climate Change Adaptation Advisory Committee related to strip till and no-till in southern Huron County. Mike and his family farm 2,500 acres. Thank you, Mike, for all your efforts.
Mike Strang. Our operation, we call it Strang Farms. We farm just outside of Exeter, Ontario, kind of between Exeter and Hensel. We run roughly 2,500 acres of cash crops. We don't really have any livestock other than a few cats and dogs. But we really focus our operation on the conservation tillage and cover crops. And we do a few things that are what we would consider unconventional. And you can see on the screen here, we do strip-tilled, twin row, corn, soybeans, edible beans. We also grow winter wheat, usually hard red winter wheat, some oats, and even a bit of alfalfa. And contact information at the bottom. You're welcome to contact us or contact me through any of that. It's my Twitter handle, Farmer Strang, and it's my brother's Twitter handle at One Quantum, and I farm with him as well as my dad and a couple other employees. So just kind of an explanation of between strip till, no till, conventional farming. Conventional is what we usually consider full width tillage. So more or less every square foot of that farm or field is worked with a tillage implement. The residue is buried, the soil is exposed, and there's very, very little plant residue left on the surface to protect the soil. The plant residue, being alive or dead, above the soil will protect that soil from water and wind erosion. We also talk about structure and tillage. It breaks up that soil and works into smaller pieces, and this can in fact impact the soil biota, the populations. What I mean biota, I mean bacteria, fungi, nematodes, all those microorganisms, and even some of the bigger ones you'd be familiar with, like earthworms and mice and all those things. Every tillage pass impacts the population. We often akin it to imagine living in a town and think about the town of Exeter, say, and a tillage pass is like somebody coming through with a bulldozer and knocking down everybody's house. It's a big disturbance. So when we talk about no-till, this is where the exact other spectrum of it, where you're doing very, very little disturbed soil. You're just coming in with a planter and kind of sliding the seeds into the soil and not doing any tillage. And it's very good for the soil biota, the populations, that kind of stuff. But there's often a yield drag. And that's, something lots of no-till guys argue with me, but there are certain crops that are very well adapted to no-till. Soybeans are good. Winter wheat's very good. Something like corn, alfalfa, they struggle a little bit more. And so you can often increase your yields with a little bit of tillage. So strip till is a practice that we do. We do both strip till and no till, but strip till, especially for corn, and I should have mentioned the edible beans as well, can be impacted by in no till. So we do tillage, but is really only in a small strip or a zone, and only about a third of the field is disturbed. So 2/3 of the field is left alone. But we will turn over the soil in the 1/3 of the zone. So it's kind of a best of both worlds. And, we keep lots of soil covered, but we also can keep our yields up, very, very competitive with conventional full width tillage. I kind of hit some of these points already, but why strip till? Again, it, minimizes the area of the field tilled, but also in this we do twin row, which is a little unique. Most corn is grown in a single row, 30 inches apart. We will actually put 2 rows of corn, and they're about 7.5 inches apart on what we call 30-inch centers, and we'll do that for edible beans as well, and soybeans. And the reason we did that was we wanted to narrow the corn rows to get a little better light interception and increase yields. There is some data suggests that if the corn rows are closer together, that we would increase yields. And we do actually expect about a 7% increase, which would be, say 3 to 5% increase in yield. We also use cover crops in the twin row system. We can put cover crops in between those rows and various parts of our rotation. And we are working towards, and not 100% there yet, but working towards having a living plant growing on all of our acres 12 months of the year. And that is, it protects the soil from wind and water erosion, but it also, the plants help those populations, the bacteria, the fungal, the earthworms. There's a lot of interaction going on there. And the more we can keep something living in that soil, the healthier that soil becomes. Zone till also allows us to strategically place nutrients, our fertilizers, our nitrogens, our phosphorus, potassiums, even micronutrients. We can put those in the zone really close to where the plant roots are going to be, as opposed to a more conventional approach where you would just spread those all across the field as evenly as possible. We're concentrating those nutrients where the roots are going to intercept with them better, and we can actually get away with a little lower rate of fertilizers because of that. So when do we strip till? We will strip till any wheat stubble. Wheat crop leaves a lot of residue behind and can leave the soil cold and damp in the spring. We try to plant, so we definitely like to strip till the wheat stubble, and then we'll do another pass in the spring, mostly to incorporate the fertilizer. It does, soil a little nicer. And what I tell people is, our zone is very much where we plant the seed is very much like somebody went and plowed and cultivated once or twice, and it's conventional tillage right in that zone, but just where the seed's going to go, not the other 2/3 of the field. Soybeans, we won't bother with strip tilling in the spring. They're typically grown after corn, and we'll do a single strip till pass in the spring to put a few nutrients in the ground and make that soil a little more suitable to planting into. And again, edible beans, we usually follow edible beans after soybeans. There's not really a lot of residue there in the fall. I often do like to put a cover crop ahead of the edible beans, but we only spring strip till because, again, there's not much residue in the fall to worry about with fall and soybeans. But if we were doing to follow a wheat crop with all that residue, we would do that with the fall strip till with the edible beans. Just wanted to show some pictures of our machine here. The red tanks at the top, those are 2 fertilizer bins. And this is what we call a fall deep till setup. And so we have a deep tillage setup in the fall that we use to get down to deeper layers like gray cup compaction. But we also have shallow setup that I'll show you. Just a close up of that deep till. You can see a big cog in the middle that really brings up the soil, and a couple of containment holders at the back, those black notched wheels, and they help keep the soil to stay at the zone. And this is what that looks like in the fall. This is a little later. You can see a bit of snow there, but it creates a berm. There is still some residue on that zone, and that's not a bad thing, but lots of residue in between to protect the soil. But that soil being raised like that will actually intercept more light and will warm up and dry out quicker in the spring and help us with our planting conditions in the spring. Here, just another picture of doing strip till. That's wheat stubble. There's quite a bit of volunteer wheat there, and still making a nice zone. It's cloddy, and that's okay because those clods will break down. Just an example again of fall strip till. This is where we had a wheat crop, and we underseeded it to red clover, which is a wonderful cover crop. And you can see we're only tilling, maybe getting 20 to 25% the field tilled, because the roots of that red clover are keeping the soil very, very tight. It's not a bad thing. And the red clover is a great crop. It is difficult to establish, get an even stand. That being a very exceptional picture with a nice stand, it can be kind of patchy. And so we still work with it, but we try to improve it, get better stands. This is just kind of an extreme example. This was somebody's wheat field. They had hog manure put on it, and then they planted this cover crop. We got oats in the head. We had a few sunflowers in the head. There's some radishes like brassicas in there, and some peas, and it's a beautiful, beautiful cover crop. And our machine can actually go through there and not making a real big, beautiful zone like I showed you earlier, but it's doing some good stuff in there, and will allow them to plant into that in the spring. That most species would die with a hard frost and would be dead in the spring, and then another strip till pass, and it'd be ready to plant. So this is just kind of an image of our spring setup, and so it's a 3 coulter system, lead coulter 2 in the middle, and we're applying liquid fertilizer behind that lead coulter, and then dropping dry fertilizer in between those 2 other coulters. And the dry fertilizer gets mixed in the zone very well, and the liquid fertilizer tends to stay kind of in that middle. But it's run shallow, where the deep till was maybe 8 inches ish deep. We're running this about 3 inches. Just another picture of that setup. So the first picture was 8 rows. We expanded to 16 rows because we're tilling shallow. We can use the same horsepower and double the rows, because it didn't take as much horsepower to pull in a shallow setup. This is a picture of us no-till seeding the soybeans. The cover crop's been terminated. You can kind of see the corn residue there, and this is just straight no-tilling, which often works very nicely. But you don't get the benefit of putting nutrients in that zone where the strip till machine can do that. These are edible beans that were strip tilled into corn stalks. So you can see there's lots of residue on that soil. Protect the soil. But there is a fair bit exposed. It's dry and brown and a decent edible bean stand. But you can see where there's soybean strip tilled, and there was definitely a cover crop of some sort growing there. You can see all the residue there, and a nice stand of soybeans and lots of residue to protect the soil. So this just kind of end result. So this was strip tilled, planted, and we killed the cover crop with chemicals, probably Roundup. And it's very, in the end, there's still quite a bit of soil exposed there once the crop gets growing. But maybe we can protect the soil a little bit. And that's where we get into this planting green concept. On the next slide, you see description of planting green. It's where we still plant a crop, but it's into already a living green cover crop. We have not killed it. We've done no tillage. And one of the great benefits of this is we maximize the amount of growth the cover crop can achieve. And the longer the cover crop can grow, the longer we have roots in the soil, and we have something capturing sunlight, the healthier that soil can be. And it also provides more surface soil protection. You see example, this is a cereal rye. This is kind of the go-to for planting green. It's relatively easy to establish. It's pretty easy to plant into, and there is some head. This is more like early June. You would see something like this. I actually think that's a field where I had a bit of hairy vetch in. If you look closely, there's a bit of hairy vetch in there. And this is a picture of the machines going through there. It looks a little odd because half the tires are covered with the cereal rye, but that cereal rye is about 5 feet tall, and so we're strip tilling it and then rolling it behind the small tractors got to roll it to just make a little better seed bed. And this is what the planter looks like. You can't see the zones. It doesn't look like I've done anything, but it's been strip tilled. But that's the planter going through that strip tilled cereal rye and planting edible beans. And they're a high value crop, but and it seems a bit risky to do this kind of thing, but we actually get pretty good results. Just another picture of planting edible beans in strip tilled cereal rye. It's matted down a little more. The other picture, you can see the result of tire tracks and stuff. And that cereal crop not only helps the soil, but it will actually suppress weeds. And weeds are a tough thing to control in edible beans. And we do find the edible beans grow better with a little higher yields in that cover crop, but also the weed control is better. Again, just another picture of edible beans in the strip tilled cereal rye. A whole farm full of cereal rye, and this is just what grew. It was just what came out of the back of the combine. It's hard to get it all, and I just let it grow voluntarily, and strip tilled it in the fall, and then came back to strip till in the spring again. And we're planting corn in this situation. You can see the cereal rye is not in head. it's much earlier in the year. It's early May, and we planted corn of that, and that was very nice. And after planting, I'll come in there with a sprayer and kill that with Roundup. Yeah, that was just actually this past year, 2021. We had a really good yield off that farm. We did plant corn. It was very similar to that previous slide, but it was later in the year. It was a wet year, and the cereal rye got a bit taller. But you can see the corn growing in there. It's coming through, and the cereal rye is providing a nice cover there, and it's obviously being killed here chemically. So this is just an example of the plant stands we can get with that. You can see a nice stand of middle beans. They're pretty young there. Lots of residue around them. The earthworms are eating that cereal rye cover crop, and it's doing a nice job protecting the soil. And we can expect a decent edible bean crop from that. Just another picture, more an overview picture. You can hardly see the edible beans there, but you can see a couple lines of rows of edible beans and amongst all that residue. A close-up view of that. You can see on the left one where the rye is really heavy, and we've tried to plant the beans into there. There are some beans missing there, and that is something we challenged with and we're working at. We feel we're doing pretty good, but we can do a better job of get those beans. But lots of rye there, and it's adding carbon to the soil and helping the microbes and protecting the soil from wind and water erosion, and that has a lot of benefits downstream. Now, this is where soybeans are growing into a cover crop. I think that was cereal rye. But I just want to bring your attention to, if you notice the straw and the residue, you can see bare soil, but you see the residue kind of piled up in clumps. And each one of those is where underneath there is what we call an earthworm midden. You pull that clump of residue off and you'll find a hole, and there'll be an earthworm living there. And they come out at night and they grab the residue and they bring it towards their hole, and then they chew on it during the day. So when you see a lot of these middens or these little piles of residue, then you have a sense of how many earthworms you got, and the more the better. This is a multi-species cover crop. So we had planted this in the previous year after wheat stubble or after wheat crop, and we're planting corn into this. And this is the tractor is doing the first strip till pass. You can see a lot of flowers, which help bees, and we're able to plant into something like that. It shows a little more of that reality. That first one, like, oh my gosh, it's just a sea of green and plants, and how do you plant into that? But the fact that we strip tilled it before, we spring strip till pass, you can see the rows where we actually planted corn. It's bare soil, but being protected by that surrounding cover crop. So again, it's kind of that best of both worlds, right? You're still planting to a nice seed bed, but we also get the benefits of cover crops, lots of residue to protect the soil. And that brings me to the conclusion of the presentation. So it's really strip till, twin rows, cover crops, trying to incorporate it all together, and doing the best we can to improve soil health and improve water quality locally, and even wind erosion, air quality, that kind of stuff too. So trying to put it all together. So thank you for listening, and please don't hesitate to reach out with any questions.